Hi, in this video lecture we are going to discuss about mobile IP. So what is mobile IP? So mobile IP is the internet protocol which is used to connect with various mobile devices. So mobile devices are nothing but laptops, wireless communication devices. So the mobile IP, whenever a mobile node, that is you are using a mobile phone or laptops, whenever you are traveling from one location to another location, the location which you are is in known as home network. The location which you are traveling is known as foreign network. So the connection need to be established between home network and foreign network. So who will do this job? The job will be done by this mobile IP, right? So the mobile IP, the current versions of internet protocols are not suitable for the wireless communication network. That is, the current versions like IPv4 and IPv6, they'll provide solutions only for the fixed networks. They won't provide solution for the mobile networks. It's because the datagrams are sent between the computer based locations for the fixed networks. So hence in this situation, whenever we are using a mobile computer or mobile nodes, the IP network, IP addresses are keep on changing whenever the mobile nodes moves from one location to another location. So the existing routing protocols cannot able to uh, fit for this environment correctly. So in order to make it more comfortable, this mobile IP solves this solution, that is changing the IP addresses from one location to another location. This mobile IP solves this issue by maintaining two IP addresses. See here you can see. So two IP addresses are used by this mobile IP in order to solve the existing IP networks, IP addresses which are using only one address. Here this mobile IP uses home address and care of address. This home address is the current address of the mobile node, and care of address is the address whenever the mobile node moves from one location to another location. So I can say it with the example, like some students are studying in home and some students are studying in hostel. That is, they are staying in the campus and they are studying. The student who is staying in home, he is using, we can say he is using fixed network, and the student who is moving from home to college, that time that home address will be taken care by care of address. So in this place, this mobile IP only manages his addresses. So I hope this concept you can understand more clearly with this example. So here you can see, as I say, here you imagine this is your house and this is the college or the hostel, or you can even see wherever you are visiting a lodge or somewhere place. So this is the home network. So home network maintains a home agent. So here you can see the mobile IP topology. The internet host, the mobile host, we can say, this mobile node uses the mobile node's home address. So the mobile node home address will be there, and that will be maintained by the router. So if your mobile node is moving on to the foreign network for foreign agent, that is, you are moving from home to college or hostel, like that, any foreign network, that time the home agent, this home agent forwards the datagrams to the a foreign network through foreign agent. So here it is a, here how it happens means, with the help of routers and internet host, this process is taking place. So next, after after the datagrams, so the datagrams from the mobile node to the internet host are sent using normal IP routing procedure to the foreign network, and they are delivered to the foreign agent. The foreign agent, it forwards the datagrams to the particular internet host. So in this way the communication is happening for using mobile IP. And how this is achieving means, it is achieved through functional entities. What are the functional entities available in mobile IP is mobile node. So mobile IP, a mobile node is the host or router node, or we can simply say it is a mobile node or a laptop, like that. that is the mobile. And next one is the home agent. Home agent is the router, which we saw in previous diagram. It is a router or a mobile node on a home network which uses the datagrams of the current mobile node and delivers that datagram to the foreign network, or we can say it is a care of address. It just transfers the care of address to the foreign home through home agent. Then the foreign agent is another router. It works on the mobile node's visited network and provides the mobile node with the whole mobile node registered. So for example, you are moving, first you are moving to a mall, then you are moving to a theater, then you are moving to your college, like that you are moving. So the foreign agent will maintain all these addresses and within a foreign network. So now we will see how the mobile IP works. So here the mobile IP enables the routing of IP datagram to the mobile node. So the mobile node's home address. So home address, who maintains it? Home agent maintains the home address. The home address always identifies the mobile node with the help of internet or organization's address. So this is the organization's address, it is given here. Then whenever it is away, whenever the home network, the mobile agent is mobile IP is away from the home network, the care of address is registered. The mobile IP need to register for the care of address to the home agent. Okay, so now the mobile IP is registering for the care of address. Then the home agent redirects the datagrams to the home network to the care of address by connecting the new IP header to the mobile node's care of address. The new header then encapsulates the original IP datagram to the home address, and it delivers the care of address. This type of encapsulation is known as tunneling. Okay, so tunneling is the whole, I will explain once again the tunneling concept. Whenever the home agent redirects the datagram from home network to the care of address, that time a new IP header will be assigned to the current address, that is current address plus care of address. So this care of address need to be sent to the foreign network through a process. That process is called tunneling. So tunneling will be having two addresses. Means here I am just considering you are moving from one location to another location. Like that means you will be having current address, that is home address plus a care of address. Two addresses are there. So it depends on the locations which the mobile node is receiving. So all these addresses will be given encapsulated through the process of tunneling. So here the mobile node residing in this home network. So network A. So here a network A. So in this network A, before the mobile IP moves to the foreign network, network B, both the network supports mobile IP. Just in this situation, both the networks need to support mobile IP. Then only they can communicate. So with mobile IP and fixed IP, this setup won't work. The mobile node is always associated with this home network by its permanent address, like 128. Here it is given 128.226.3.30. So this is the permanent address it is given here. So 30. Then through our network A, the home agent datagram destined to the mobile node are delivered to the normal IP process. The mobile node moving to a foreign network, here network B, it moves to the foreign network. I can show in this diagram foreign network B. Here it moves to the foreign network. That time the network A encapsulates and send it to foreign agent on network B. Upon receiving the encapsulated datagram, the foreign agent strips off the outer header and delivers the datagram to the mobile node visiting network B. So here the care of address belongs to a foreign agent mobile node with the help of DHCP or point-to-point protocol. Who is doing these things? Whether the DHCP, dynamic host configuration protocol, or a point-to-point protocol will be handling all these things. So in this way, the communication takes place. Now the important point here people need to think is registration process. So registration means the home agent registers, informs of the current location, and the mobile node moves from home network to a foreign network, or from one foreign network to another foreign network. It chooses the foreign agent on the new network. It uses a registration message to the home agent. That is, it is informed, like you are visiting to one place to another place, you are informing your parents or you're informing your friends, I am here, I am in this current location. Likewise, here it informs a home agent that I am registered, like registered here, I'm here, like that. This is a registration process taking place in mobile network. So here the mobile IP with reverse tunneling. So reverse tunneling is needed whenever whenever it wants to uh, uh, connect to the current location. So the previous description of the mobile IP, like how many places it travels, all these things will be there in the encapsulated in its header. That all this can be requested for reverse tunneling between the foreign agent and the home agent whenever a mobile node registers, and a reverse tunnel is used between the mobile node's care of address and terminates its home agent. So in this diagram you can see, so mobile node foreign agent and reverse tunnel forward tunnel. So forward tunnel is with the home agent to foreign agent, and reverse tunneling is happening between foreign agent to home agent. So in this way the connection takes place with the help of mobile IP. The concept is very simple. It maintains two IP addresses, home address and care of address, home agent and foreign agent, tunneling, forward tunneling and reverse tunneling. So these are the concepts with mobile IP. Hope you can understand how the mobile IP is working. So we'll see with the next lecture soon. Thank you. Hi, in this video lecture, we are going to discuss DHCP, that is Dynamic Host Configuration Protocol. So, what is the use of Host Configuration Protocol? So, Dynamic Host Configuration Protocol is used by network management technique. It assigns the IP addresses dynamically for the network configuration, which are connected with the devices. So, the main purpose is managing and automating the IP addresses. It was done by the administrators to make every device on the network to provide unique addresses and the appropriate configuration parameters. So here you can see the client server architecture of the uh, DHCP. So client server architecture. So it has the client and server. So initially a broadcast request is sent by the connected client. So this is a client. It sends the broadcast request to the available DHCP servers on the network with the help of DHCP discover message. So in response to the client's request, the DHCP server provide an IP address with the other configuration options such as subnet mask, default gateway, and DNS server addresses. After receiving it, the client contacts the particular DHCP server and requests further request for the configuration which it needs. After that, the requested configuration is sent to the client by the DHCP server, and it acknowledges the request. That is, the server acknowledges the request. That is, yeah, this is the thing. I have all these configurations. You can connect with me, like that. The server acknowledges to the client, and finally, and after deciding on the options which the client gets satisfied, the DHCP server to the requested configuration is available. The connection is being established, and the DHCP server acknowledges the request which was sent by the client. So this is the architecture where a request is sent via MAC broadcast things. Now we can see components of DHCP. So in this components of DHCP, it has a DHCP server, DHCP client, DHCP relay, IP address pool, subnets and lease. In this DHCP server, So what is the work of a server? So it is a server which stores the IP addresses and other configuration of the related data, like which DNS it can connect, like that. Then the client, it is a device. The client device can be like a laptop, computer, tablet, or it can be any other electronic gadget where the client want to connect to the server. The DHCP relay is another component which is used to conduct a communication with uh, the client and server. And IP address pool. So in this IP address pool, it has a collection of IP addresses that DHCP server has in hand. That is, whenever a client is requesting an IP address, the server assigns the IP addresses, that also unique IP addresses, to the client. So these things are maintained by this IP address pools. Then the subnet. So subnet is maintains a partition of the network to control by the DHCP server, and each section, like section A, section B, like that, it maintains a subnets. And finally, lease. So lease is a method where it has the duration for which the data is obtained by the server is valid or not, and it talks about the expiration of the communication. Once the communication has expired, then the tenant, that is the client, need to reassign a communication. If you see the working of DHCP in this diagram, it has the two clients, PC0 and PC1, and a server. And how the connection is established here. Here is the client can use a TCP/IP protocol on application layer with the needed DHCP functions. The server assigns the dynamic IP addresses to the client with the configuration information, such as the server has the TCP/IP protocol with the application layers, HTTP, like that. Then the client may use some other ports, which the port, even the client requests for a particular port, this port is available for communication. Yeah, this is for example, it can request for a port number 68 or 67 for DHCP protocol. Then it may also use some UDP services or TCP services based on the availability of the server. So like a pool of addresses. So here the server, as we already saw, IP address pool, a server maintains the pool of IP addresses. So it can also use a procedure like DORA, DORA, DORA procedure for client and server exchange for DHCP messages to establish a communication. And it involves 8 DHCP messages to contact between client and server. So this, in this way, it working is happening between client and. Finally, if we see the advantages of DHCP, DHCP uses dynamic assignment of IP addresses, so which makes the network administrator to make his job very easy. No need for any manual assignments. And once the communication happens between server and client, they can easily remove the connection because it uses lease concept. In lease concept, it will be getting the tenant will occupy for the particular moment where it needs. So it is automatic assignments and automatic releasing of the IP addresses. So these are the advantages of DHCP protocol. I will meet you soon in next session. Thank you. Hi, in this video lecture, we are going to see snooping TCP. Before understanding snooping TCP, we will just see what the basic concepts of snooping TCP. Snooping TCP is a protocol. It's not a standard protocol of networking. In sometimes the TCP snooping feature found in some network switches. So that's all about snooping TCP. So what a snooping TCP mechanism is? Snooping TCP switches are used to inspect and manipulate TCP traffic which are passing through the switch. So what type of manipulation it will do, or what type of checking it will do? It will monitor, analyze or control the TCP connections, how the TCP flow is there. So for example, I can say it can do packet inspection, means packets are transferring from whether the header and payload are correctly transferred, and connection tracking. So connection tracking in the sense the switch itself will provide a where the originated source and where the destination IP address, like the connection tracking and what the port number they are going to access. For example, in HTTP, what is the port, like each transaction has various types of port numbers, so all this connection tracking will be done. And then it will also do some manipulation for the packets. For example, it might be able to modify the payload of packets and alter some flags of the TCPs, or it can terminate the TCP connections. The snooping TCP is used for various purposes in networking, such as network monitoring and for security analysis, and verification of network policies. But the TCP snooping main features are it can communicate with various types of network equipment, and it is not a standard part of TCP itself. It is just a network equipment. So so these are some of the basics we need to understand about snooping TCP. Now we will see how it is being working and everything. So like in TCP, general TCP will be seeing if any connection loss occurs. Okay, it won't send the acknowledgement. So in this snooping TCP, when all the packets are sent and acknowledgements are received by the sender from the recipient, and if any gaps are found in the acknowledgement, then that time the snooping TCP will work. So here you can see the architecture of snooping TCP. So it also provides the end-to-end TCP connections. So here the server and the wired network or the corresponding host does the concept of buffering of data with the help of foreign agent. But we will see what is the actual role of this foreign agent. The foreign agent delays a packet until the acknowledgement is received. That is, a sender is sending a message and receiver is receiving the message, and the and the acknowledgement need to send between both. So if any acknowledgement is delayed, then it buffers the packet. The foreign agent plays a major role in buffering the packet. And if the acknowledgement has lost, and if it does not, any acknowledgement is received, and or it can be a repeated acknowledgements like that, it deals means the foreign agent transmits the particular packet from the buffer. So, so the foreign agent also have some timings where within the particular time, if the transaction is not succeeded, then it can resend the buffered packets to the wireless link. The foreign agent also notices the missing packets during the transmission, and it sends the transmits the corresponding packets, and even it also sends the negative acknowledgements to the mobile node that you did not receive the particular packet. So, and further, the TCP, if any packets are missing, the TCP automatically rearranges the packets to the corresponding node. As we already saw, there is a sequence number. Based on the sequence number, the packets are transferring. So the TCP automatically rearranges the packets where the nodes need to receive. And eavesdropping is a big issue of packets, where people can tamper the information, and the corresponding nodes timeout function remains the operational, and if any crashes occur, that also are retransmitted by the foreign agent. And if you see further, the duplicate packets which are already transmitted locally from the nodes, the foreign agent discards the unwanted duplicate packets, because these duplicate packets are not needed for the extra traffic which is avoided by the foreign agent. And additionally, in order to maintain transparency between the nodes, the foreign agent acknowledges the packet with the mobile nodes, not with the stationary nodes. So here you have to understand the foreign agent plays the major crucial role of transmission of snooping TCP by buffering the packets. Hope you understood the concept. We will soon meet in next topic. Thank you. Hi, in this video lecture, we are going to discuss about mobile TCP. So, what is mobile TCP? How it is going to work? Advantages and disadvantages. Everything we are going to discuss. So, mobile TCP. TCP is a transmission control protocol like it is like a TCP. So TCP establishes network connection between various applications. So when we are talking about mobile devices, so what is the difference is, so this TCP connection used to establish web browsing, emails, application exchange between mobile devices. So the mobile devices uses TCP connections with the intended servers and ensures the reliability of the service between mobile devices. That is, the delivery of data packets from sender to receiver need to be delivered, and it ensures the reliable communication between mobile devices. So how this is maintained, so it is very crucial to maintain the quality of the communications to mobile devices. So the TCP, how it is being implemented in mobile devices are considering various connection establishments process. So we will see how the connection establishment is happening. The connection establishment is happening like this is the diagram you can see. So the connection establishment starts with similar like handshaking, right? So in simple TCP, the handshake will happen. So similarly, here also a handshake happens between mobile devices, and it is especially it is a three-way handshake procedure. Like the mobile device sends a synchronization packet to the server. So synchronization with the server for initializing the connection. The server responds with synchronization acknowledgement packet, and then the mobile device also sends an acknowledgement and the connection is established. So it's a three-way. The first thing is the mobile device to a server as synchronization packet. Then the server to mobile device and syn ACK packets. Then in response, the mobile device acknowledges a acknowledgement packet. So in this way, the connection is being established and the data are getting transferred. So when we are talking about data transfer, so the connection is established, and the TCP ensures that delivery is reliable. With the main important concept is sequence number and acknowledgements. So sequence numbers are number where each packet maintains the sequence number. So it used to maintain the order of packet delivery. So simple in layman term I can say 1 2 3. So if in example, if the packet 3 is missing, then it won't get acknowledgement. Again it will start sending the packet 3 like that. So sequence number plays a major role. And then when we are talking about the flow, okay, so the flow of the packet. So the flow, as I said, the acknowledgement of the packet is also a major thing. Then how the connections are happening, the flow of the packets, how it is being ensured is the flow control. So TCP uses a mechanism called flow control, where the sender does not overwhelm your receiver with data. So that is very important for mobile devices because they are having very limited bandwidth. So the receiver advertises a window size, right? So this is my size of the window where I can have this much packets. So the sender adjusts its transmission rate based on the receiver's window size, and after that the flow is controlled. Finally, the connection will be terminated uh, by the mobile by the TCP, and connections are terminated. TCP terminates a connection with the four-way handshake concepts. So initially, that is the mobile device sends a FIN message with the particular server. The server responds acknowledgement packet, and then the server then sends its own FIN, that is finish the transaction packet. So in mobile network, TCP may also use some issues are there like uh, latency issues, packet loss, and bandwidth issues. All these issues are there. So the mobile devices and networks may use optimization concepts to accelerate the buffer management to improve the performance of the TCP. So now if we see the advantages of TCP, so it is an end-to-end semantics. As I already told, handshaking is done between sender and receiver. So end-to-end semantics is being preserved. Apart from that, it also maintains the reliability of the data. So reliability of the data whenever I lost packets, okay, in correct order. So who is doing that with the help of sequence number? And then the flow control. So flow control, it also maintains the flow control between sender and receiver by limiting the bandwidth of the sender, like that. And then error checking. So whenever any error occurs, okay, so it retransmit the corrupted or lost packets and ensures the data integrity. And finally, compatibility of the packets, it ensures that the mobile devices are compatible, like operating systems are compatible, applications are compatible for the senders. So these things are explained here. And then the disadvantages, if we see, the packet loss occurs uh, like high overhead. Okay, whenever the server is keep on sending it, reliability and flow control, error checking plays a major thing. And this leads to increased latency and high bandwidth usage. So overhead will occur. And performance issues, if we see, TCP's congestion control algorithms may not perform optimally. Optimal performance is not achieved, and high latency or high loss environments are there. And battery consumption, so the battery consumption is also a issue with the mobile IP, where it whenever a packet is lost, so retransmission need to be done. That time the battery consumption will be more for mobile TCP. Then the connection setup, connection establishments, everything, the latency of the network, mobile network may be very less in terms of mobile TCP. And finally, the TCP may suffer for reliability and compatibility in such low latency scenarios. And in that scenarios, people can use the UDP or optimized versions of TCP for better performance. So I hope this is a simple working of mobile TCP. We'll see you in next session. Thank you. Hi, in this video lecture, we are going to discuss a basic transmission control TCP. So transmission control TCP, it is a connection oriented protocol. So connection oriented in the sense both sender and receiver will acknowledge each other whenever they are communicating, and it exchanges uh, informations with network with the help of IP protocol, internet protocol. So in the OSI layer, TCP is located in transport layer. So the TCP is used to establish the virtual connection between the sender and receiver, and it ensures the reliable information transmission between sender and receiver. So if you see, effective that internet protocol is a protocol which is used to communicate with one devices to other devices using network layer. So every gadgets like computer, laptop, mobile, everything. So if you see mobile communication, they are using mobile IP. So this unique IP address enables the perfect communication of data between various devices. So how the TCP is working? This TCP is working with the data. The data is bundled, okay, bundle and assemble and reassemble concepts. So initially, the any message, the original message are arranged in a bundle, and these messages are destined to a particular destination with the help of a sequence numbers. And once the messages are delivered to the receiver, then it retains the information which are in the bundle. So you can see in this diagram, so once the messages are divided into bundle, large messages are divided into small bundles. So if one route is congested but the destined is still same, the bundles may take the different routes. So the sender sends the synchronization to the router, and then the router says, yeah, I received your synchronization, and it acknowledges. Then it sends the acknowledgement. After that, they both can transfer the messages. This is simple handshaking mechanism with both the server and the receiver. So the segment number system. So as I said, the bundle, each bundle has the segment numbers, and the data bytes which need to be transferred with the byte number, and the segment number are given a sequence number. So the received segments are acknowledged by the receiver when they are receiving the segments. And the connection oriented communication maintains the reliability of the transmission between sender and receiver. So, and then it also maintains a full duplex communication, means the data can be sent simultaneously from the sender as well as the receiver parallelly. So which is used to provide more efficiency between sender and receiver. Then the flow control. So flow control is very important, which is guaranteed for the sender and receiver, where the amount of data can be sent and received continuously by the sender and receiver. And finally, it also suggests for error control and congestion control. Whenever it identifies the error detection mechanism is used to identify the duplicate segments, out of order segments, like and lost segments, etc., or corrector segments. And congestion control. So congestion control, whenever a congestion occurs in between the communication, so the congestion control mechanism solves this issue with the extent of providing additional data volume for the sender. So I hope you understood the basics communication of TCP/IP and how the IP protocol is used in transferring with the TCP protocol, and it also provides a perfect handshaking mechanism, and like both sender and receiver can transfer packets at the same time. Flow control is provided, error control is provided, congestion control is provided, and this is the best transport layer protocol for communicating with sender and receiver. Soon we will meet with next topic. Thank you. Hi, in this video lecture, we are going to see wireless access protocols. So, wireless access protocol, where we are using this protocol, what is the purpose of the protocol, everything we will discuss in this lecture. So, wireless access protocol is used to communicate with wireless devices. So, it is in hierarchical structure. This protocol is similar to TCP/IP protocol. So wireless access protocol, we can say it is a wireless application protocol also. So this protocol is used for micro browsers in internet devices such as mobile devices, like that. So this wireless access protocol uses WML, that is a wireless markup language script, which is similar to HTML script. This wireless this WML script is which is a XML application which is used to create communication of web application with mobile devices. So this is an interesting story behind this wireless access protocol. It is created in 1998, which was founded by Ericsson, Motorola, Nokia companies for communication with wireless devices, especially for mobile devices. This protocol uses a web forum, and in 2002 this web forum was merged with the industry resulting open mobile alliances. Now we will see the web model. So in this model, here we are having a client and web server and a gateway. So the whenever the user opens a mini browser, he views the website. So this is done with the help of web protocol in mobile devices, and a URL encoded request is given to a web gateway. The web request is converted by the gateway into a standard HTTP URL request certificate. This request is sent to the designated web server, and in response, which is sent to the web gateway with the WML file to the mini browser. In this way, the client gets the data between web server and a client through the gateway. So, like a simple HTML script, how the web applications are working. Similarly, the WML scripts are used to get the data with the client to the server. So this is the application protocol. You can see here the topmost is the application layer, wireless application layer, and the session layer, and then transport layer, security layer, and finally transport layer. So here it is a transaction layer. We will see the working of each and everything. So application layer, so the wireless application environment, WAE stands for wireless application environment. So this is the topmost layer. So this layer involves programming languages for content development for WML for the mobile devices. The user may request some content to the server, and those content development is done with this application environment. Then wireless session protocol. So wireless session protocol, WSCP. So it is contains in session layer. It is used to offer a quick services such as suspension of a communication, reconnection of a connections, etc. All those things are handled with this session layer. Next thing is transaction layer. This transaction layer, wireless transaction protocol, WTP, is involved in this layer. So it is a component of TCP/IP, and it operates on top of UDP, that is user datagram protocol. So which is used to support a transaction communication between between the entities. And next is a security protocol, that is a wireless transaction layer security, WTLS. This transaction layer security provides the privacy, authentication, and integrity communication with the end devices for providing secure communication. The last thing is the transport layer. So that is a wireless datagram protocol, WDP, wireless datagram protocol. So this protocol is used to communicate with higher layers of the web protocol stack, and it provides the uniform data format. I hope you understood the basic working of web protocol, and how it is being connected with various layers, and how it is working. The working is similar to any OSI layer or TCP layer. So we will meet soon with the next topic. Thank you. Hi, in this video lecture, we are going to discuss radio wave propagation in wireless communication. So first we will see how the radio waves are being used for wireless communication. So the electromagnetic radiation is main important factor of radio wave communication. So the electromagnetic waves are accelerated, navigated for communication with weather forecasting, medical imaging technology, and other fields of radio communication. The electromagnetic spectrums are longest wavelength which are used for wireless communication systems. So we will see the propagation of radio waves. How the radio waves are being propagated is the radio waves can propagate solid materials, liquids, vacuum, and other media. The wavelength and the frequency of the radio waves are determined through the type of materials. If it processed through liquids, the density will vary, and the frequency, amplitude, everything will vary for the radio waves. If it is a vacuum, then the amplitude, frequency, and phase of the radio wave will be in some other manner. So like the wavelength depends on the types of the medium which it propagates. Now we can see the mode of radio wave propagation. So they can propagate as a ground wave, skywave and space wave. So these are basic three modes of propagation of radio waves. We will see one by one how the communication is being taking place in skywave propagation. So in skywave propagation, it is through air. So it is using an antenna and the ionosphere layer as a sky, and the signals are received by the antenna. So these are represented as for transmitting, the signal is represented as TX, and for receiving the and receiving antenna is represented as RX. And the atmosphere, so in the earth atmosphere is made up of ionized gases, and it also has the plasmas in ionosphere, so which will cover our earth for dangerous radio propagations. If you see here the skywave propagation, it takes place in ionosphere, so ionosphere layer. So the frequencies are ranged with 3 to 30 megahertz in this skywave propagation. You can see in this diagram the angle at which the radio waves penetrate are high density. So this is the earth, and this is the ionosphere, and it has the more height range where the sky waves are being propagated. When there is no phenomena of reflection, refraction, or diffraction for transmitting the radio waves, the antennas are used to propagate the signals. So line of sight of transmission or direct wave propagations are used for this sky wave propagation. So next we will see space wave propagation. In space wave propagation, it is just a short range. You can see it is just a short range of frequency are usually used to transfer, and the radio waves operate on 100 megahertz and maximum range of 40 kilometers only. So where they are applicable, they are used in wireless LANs, mobile phones, television transmission, remote sensing applications like that. Then we will see ground wave propagation. Ground wave propagation is used for grounds in the level of ground level, where the transmitted waves frequency and transmitted strength and characteristics are depending on the earth surface and atmosphere, that building heights and everything, or the how the communication takes place and everything. So here you can see in this diagram, so the earth and ground wave, it is very small range which has 100 to 1000 kilometer, and the frequency also very minimal, where 3 kilohertz to 3 megahertz the frequency is used. And now we will see further transmission of radio waves, like tropospheric scatter transmission. In this transmission, it operates using the bounced space of the atmosphere, like dust or water droplets, where it can scatter the signal to various directions. So in wireless communication, there are various radio wave propagation modes are there in troposphere, especially in tropospheric transmission, like longest distance communication, or it can be used to communicate without obstructions above the earth's surface. So in tropospheric scatter transmission, the ground wave propagates the benefit of being able to travel with particular distances with the help of repeaters and other devices, and the signal's quality can be improved by the tropospheric conditions and power of the transmitters, and where the diminishing and increasing distances. So these decides the tropospheric scatter transmission. Now we will see sky wave transmission. So sky wave transmission is based on the long distance communication, which propagates over the terrain. So without the structures of obstructions, radio waves can travel significant distance due to its surface curvature. So ground waves are very benefited with the greater distances with the help of repeaters or other devices, and further the radio waves conditions are diminished or increased with the help of the repeaters, like that. So next we will see line of sight propagation. In line of sight propagation, this method is used for very short distances, say for few miles. So there are underlined line of sight between the transmitter and the receiver for the radio waves to move a straight line. And the capacity of the line of sight propagation depends on the signal over a small distance in one of the advantages of the thing, but the drawback here is the signal's range might be reduced when it passes through high buildings or hills or trees. So this is problem with this line of sight propagation. Then tropospheric propagation. In this tropospheric propagation, it is employed with the short range with very few miles. There can be a line of sight between the transmitter and the receiver of the radio waves to move a straight line communication, which depends on the signal with the small distances. And this is the advantage of the communication. But the drawback is the signal's range might be reduced with the buildings, trees and buildings, which already we saw for line of sight propagation. So next is scatter propagation. In the scatter propagation, so this is used to communicate with short and medium distance places like buildings, mountains, and it scatters the radio waves, which enables the radio waves to get the receivers. The advantage of this scatter propagation is it transmits a signal in places where the propagation might be hindered due to communication points. And further, the signal may be impacted by variations in the topographic or the locations of the obstructions, which is a major drawback of the scatter propagation. Like when communicating over short to medium distances, when you face some obstructions like buildings, mountains, or trees, the mode of propagation will be a main issue for this. So these obstructions scatter the radio waves and it will disrupt the communications with the receiver. But it has some advantage, like the propagation may be more reliable with the correct proper signals and proper mode of propagation. And like that, if the locations except the hinder topography or locations, this is somewhat advantageous where it is used for propagating transmitted signals with good quality. So I hope you people understood various communication of electromagnetic radiation. So we will see soon with another topic. Thank you. Hi all, in this video lecture we are going to discuss ad hoc networks. So ad hoc network, it is in this diagram you can see it is a decentralized types of wireless network which doesn't rely on any pre-existing infrastructures. Like pre-existing infrastructure in the sense it doesn't rely on any routers or wired networks or any access points in the wireless communication. So any node can connect with any other nodes at any time. That is the concept of ad hoc networks, and that too in the dynamic basics. Okay, so that is the thing with this ad hoc network. So the introduction, as I already said, it is doesn't has any centralized management or any established infrastructure. So every device has the ability to function as both the router as well as the host. So that the name ad hoc forms the on the spot network. So it can communicate with any other types of devices at any time. So there are three types of ad hoc networks available. One is mobile ad hoc networks. The second one is wireless sensor networks. The third one is vehicular ad hoc networks. So if you see the characteristics of ad hoc networks, they are being on dynamic topology. Dynamic topology means the nodes are moved randomly in the network's topology and can change their topology with unpredictability. The nodes can join or leave the network at any time. So next thing is multi-hop routing or multi-hop communication. So nodes within the ad hoc networks can communicate directly with other nodes in the transmitter transmission range. So for that, the nodes, in some cases, if they are want to communicate outside the range, the data is forwarded via intermediate nodes with multi-hops. So this is the concept of multi-hop routing. And next is the decentralized control. So decentralized control, there, since there is no any router available in the networking, so the mobile nodes, that is the nodes in the communication, doesn't need to get any permission from any router or like that. So there is a no control, that is, it is a decentralized control. And self organizing, so self organizing, or we can say it is a self configuration network. The network configurations itself automatically, without any human intervention, can form a network and communicate. So the nodes, a single node is capable of discovering other nodes by establishing a route on the communication path. So these are the characteristics of ad hoc networks. Now we will see the applications of ad hoc networks. So the ad hoc networks are mainly first used in military communications. So military communications where it will be applicable is in the battlefield. So in the battlefield communications, where a fixed infrastructure is not necessary, and it is not at all feasible in military communications. So this ad hoc networks enables the soldiers and equipments to communicate over varying distances and conditions. So this is the one main advantage, or we can say the application of ad hoc networks. Then the next application is emergency situations. So emergency situation, we can say like disaster management, or in any other emergency environments, then there is no need for any fixed infrastructures. So the node can come dynamically establish a communication with the networks available in the range and can communicate. So another application is a sensor networking. So sensor networking or smart networking, which are useful for home or office automation with various devices to communicate and coordinate with these networks. And vehicle networks, previously we saw type, that is vehicle ad hoc networking or vehicle networking. Like vehicle networking can be used to communicate vehicles, like road safety, or vehicle to vehicle communication, vehicle to infrastructure communication. So infrastructure in the sense here, like any routing sites, like infrastructure or infrastructure to vehicle communications, all these things are provided with this ad hoc network. So next, what are the challenging of ad hoc networks? So there are various challenges are there, but here it is listed only four challenges. So routing is a big challenge in ad hoc networks. Why it is a challenge means, in multi-hop networking visa, whenever a node wants to communicate with the node which is outside the range, the routing will be a tedious one. So for that, it need to establish a route request mechanism, route replay mechanism, like that. And the particular route establishment process, it should be the routing nodes, sender and receiver, should be in the same range, and both the request and reply package should be synchronized, everything is there. The next thing is a security issue. So obviously, since the network is formed in ad hoc manner, it suffers for various security attacks. Like attacks, if you see, like denial of service attack, black hole attack, wormhole attack, like flooding attacks, various attacks will happen. So the secure routing protocol should be designed accordingly to avoid this type of security problems in ad hoc networks. And power consumption, so power consumption is a major issue with this ad hoc routing. Like in this power consumption, since it is an ad hoc and it doesn't rely on any base station or any fixed infrastructure for powering the things, so it should be very constraints are there for powers. And scalability, so scalability, when for small environment like home, like that, it is easy to maintain, but it is whenever it is for larger scale, larger number of networks, so that time the scalability is a challenging thing for this ad hoc network. So if you see the protocols available by ad hoc networks are various types are there. We will see just an example. AODV. AODV is ad hoc on demand distance vector routing protocol. It is a reactive routing protocol, means the routes are established whenever it is necessary. So how the communication is happening between sender and receiver is the route discovery process, that is a route request, route replay. So this is a route discovery process. So route discovery process, it is used to find the path to the destination. The next protocol is dynamic source routing protocol. The dynamic source routing protocol is the another reactive routing protocol. It uses a source routing, means a node maintains a route which has some cache, contains the source routes which it is already learned. So it is a source routing protocol. The next protocol is the OLSR protocol, optimized link state routing protocol. So it is also a proactive routing protocol. So in this proactive routing protocol, it completely maintains the routing informations of the current setup in this routing table. Okay, so it uses periodic control messages to update the routing table. That is where it has sender, receiver, intermediate nodes. All the details are maintained in the periodic messages with the help of routing tables. Then the last one is the geographic routing protocol. So geographic routing protocol are physical location of nodes which make forwarding decisions, or greedy perimeter stateless routing, or location aided routing. All these are example of this geographic routing protocol. So the ad hoc network represents a flexible and adaptive networking paradigm for the environment, which are different from conventional infrastructure based networking. So I hope you understood what is the ad hoc network. Soon we will meet with next lecture. Thank you. Hi all, in this video lecture we are going to see in detail about ad hoc routing protocol. So ad hoc networking, as we already discussed, it is a decentralized type of wireless network, and it need to establish the route when on-demand routing, that is whenever four nodes or five nodes, some nodes are joining, it will establish a communication among them, and the protocols which are used in this ad hoc routing need to maintain the routes between sender and receiver and intermediate nodes in data communication. So see the types here, there are three types of routing are there. One is proactive, reactive, and hybrid. So we will discuss proactive routing algorithms. In proactive routing algorithm, the first algorithm is DSDV. So DSDV is a destination sequence distance vector routing algorithm. So the distance vector algorithm is based on classical Bellman-Ford algorithm. So this algorithm is used to provide loop-free routes and avoids routing inconsistencies between sender and receiver. So the main key features of this algorithm include sequence number, that is each routing table entry is maintained with the sequence number which are used to generated by the destination node. This sequence number is used to distinguish the stale routes from the fresh ones, preventing the routing loops. And this DSDV also provides the concept of periodic updates. So periodic updates in the sense nodes periodically can transmit and maintain the topology information such as any overhead in the network or dynamic network. Everything will be handled with this periodic update information. Then the operation of this DSDV includes routing table maintenance. So routing table maintenance, it will list all available destinations in the routing table, and then the updates are with the periodic, that is a regular time interval will be triggered by the routing table itself. Then route selection will be based on selecting the routes with one of the highest sequence numbers, that is the most sequence number, and then the one which the fewer hops, that is the sequence number will be large and hop selection will be very minimal. So main advantage of this algorithm is it provides loop free and it is very simple, but the problem with this algorithm is it has higher overhead with periodic updates, and it is not scalable for dynamic adaptation of the networking. So the next algorithm is OLSR, that is optimized link state routing routing algorithm. This is also a proactive link state routing algorithm. So it is used to reduce the overhead in the link state updates in wireless ad hoc networks. The main key features include multi-point relays, that is MRPs. MRPs are the number of transmissions required for flooding control messages. Only MRPs forward link state information, which are used to reduce the broadcast messages. And with DSTV, it also provides periodic updates of the messages and maintains a link state information. That is, each node maintains the topology information about the network to compute the shortest path between each nodes. And the MRP selection, that is multi-point relay selection, will be based on neighbors to act on MRPs, which are responsible for forwarding control messages. The control messages are like hello messages or discover neighborhood messages, like topology control TC messages, to distribute the topology information. The routing is calculated with the help of link state information to compute the shortest path routes to the destinations. The main advantage of this OLSR is it provides efficient in dense networks with the high node mobility, and the control messages are very minimal. But the drawbacks is the power consumption and memory maintenance is very larger, and performance will be degraded with the high dynamic network moving environment. So the next proactive routing algorithm is WRP. The WRP is wireless routing protocol. W is wireless routing protocol algorithm. It is also based on the Bellman-Ford algorithm to ensure reliable and efficient communication. So the main features are multiple tables. So this WRP maintains the multiple tables. For example, distance table, routing table, link cost table, and message retransmission list. All these are maintained with this WRP. Then it also provides error correction mechanisms. So error correction mechanisms for exchange of any errors occurred between sender and receiver, and it also provides a loop-free transmission between sender and receiver nodes. The operations it includes each node maintains various routing informations to ensure the routing inconsistencies. It updates messages and various time intervals, and routes are being selected with the shortest path from the updated message. The advantages are, again, it provides a loop-free communication, and it quickly adapt to the topologies of the current network environment. The drawback of this algorithm is high overhead and complex implementation of various routes. So these are the proactive routing algorithms. Now we will see reactive routing algorithms. In reactive routing algorithm, the first algorithm is the ad hoc on-demand distance vector routing algorithm. Ad hoc on-demand distance vector routing algorithm is the on-demand distance vector protocol. So this algorithm maintains the routing discovery process with the help of a basic set of two messages, that is route request and route replay. So route request is used to send routing request information to the destination node where it is finding the nodes, and then intermediate nodes will transfer this route request information. So based on the sequence number, that is recent sequence number, the route replay, whichever the node is being involved, that is sent back to the source node, that is from destination node to source node. Then the advantages is it reduces the overhead, when that is how the overhead is reduced. Whenever routing is needed, that time only the communication will happen. But the drawback is initial route discovery can introduce a delay. The next topic is DSR. So DSR is dynamic source routing. So it is a source routing protocol. It maintains nodes caches with routes they have already learned information. So if a link is break or if an error occurs, that time it sends the information to the source node, and again it start transferring the messages. The main advantage are it eliminates the need of the periodic routing advertisements, and the drawbacks include source routing mechanisms can result in reducing the large headers for maintaining a longer time. Then the Tora algorithm provides temporarily ordered routing algorithm. This is also a reactive routing algorithm, and offers similar functionalities. So now we are going to discuss hybrid routing algorithms. In hybrid routing algorithms, first we are going to see zone routing protocol. In this zone routing protocol, it is based on the particular zones. The protocol, the regions are divided into zones, and it takes the advantage of both the proactive and reactive routing protocols. So how it is being done is, so using proactive routing within a local zone and reactive routing for interzone communications. The zone radius defines the radius of each zones are maintained by local routes with proactively within the radius, and the scalability is offered with reducing the control overhead, which inhibits the concepts of proactive and reactive protocols. The operations are intra-zone routing and interzone routing. In intra-zone routing, it proactively maintains the routes within each node's local zone. In inter-zone routing, it uses reactive routing for communicating between the nodes in different zones. And additionally, it provides a functionality called border casting, where each node needs to find a destination outside its zone. It uses border cast route to know the border nodes, and advantages include it reduces the control overhead by limiting the scope of preventive rating, and the route availability within the zones are provided properly, and it efficiently handles the large and dynamic networks. The drawbacks is it depends on the optimal size of zones, which can difficult to determine, and its complexity also very high in zone boundaries to detecting zone boundaries and interzone communication. Next is hierarchical state routing protocol. In this hierarchical state routing protocol, it maintains the nodes in terms of hierarchy. So simple terms, it can say it maintains nodes in terms of clusters. So cluster by cluster, the nodes are being maintained. So the operations include like each cluster. So in a hierarchy, the uh, operation, the nodes are maintained as a clusters, and the multiple levels are being given, like each and every level the operations are being performed, and so this is one level and this is another level. So in one level, the each clusters are grouped and manages for intra clusters, and then the cluster head, among this the cluster head will determine how to communicate with other cluster heads, forming the cluster hierarchy. And route discovery also with done with the help of clusters with higher level cluster heads. So the advantage is it provides all the scalability and reduces the routing table size. And but the disadvantage, cluster head election is a big issue with this protocol. And next topic is GRP. GRP is a gathering based routing protocol. Another term we can see geographic routing protocol. In this geographic routing protocol, this protocol uses its physical location of nodes to make forward the decisions. So the future of this protocol, the load location information is being maintained to obtain geographic position, and it forwards the the informations in greedy forwarding method. So greedy forwarding means wherever the node finds the neighbor nodes, it just forwards the information closest to the destination, and it provides a scalability where the large networks does not require maintain the complete routing table. The operations include like location services, greedy forwarding, and phase routing. So phase routing is in if greedy forwarding fails in some cases, then the phase routing, that is no neighbor is closer to the destination, then the phase routing is used to navigate around obstacles or avoids or voids in the networks. So the main advantage of this protocol is scalable and efficient like before, but it handle dynamic topologies as well. But the drawback is it requires accurate up-to-date location information, and performance can be affected by obstacles and voids network topology. So these are the three protocols which are used in ad hoc networking. So soon we will meet in another lecture. Thank you. Hi, in this video lecture we are going to discuss wireless mobile operating systems. So these are the types of mobile devices available. So first we will see Android. So Android is developed by Google. So it is open source software and which is used widely by various companies like Samsung, LG, like that. And it is user friendly, and the user experience is very broad range of applications and Google Play Store, like that. And then next one is iOS. So this iOS, it is developed by Apple. So this is Apple devices like iPhone, iPad, iPod Touch. All these devices uses this iOS operating systems. So this operating system works very smoothly with the user interface, and it also provides various security features, and vast ecosystems are available in the App Store by this. So next operating system we are going to discuss is Harmony OS. So Harmony OS, it is developed by Hawaii. So it was designed across various devices like smartphones, tablets, and various IoT devices. So this Hawaii reduces the reliance on Android devices. So next we are going to see Windows 10 mobile. So Windows 10 mobile device provides the functionality with the Windows operating systems, and whatever Windows platform we are using, like customizable user experiences, everything will be given by this Windows 10 mobile. The next operating system is BlackBerry operating system. So in this BlackBerry, it was developed by BlackBerry Limited. So it also provides a strong security features with physical keyboards functionalities, and it is more popular throughout the world, but it has declined in usage, right? So next is Sky OS. So Sky OS is based on different Firefox OS. So it is a feature with it also provides the features for mobile phones and smart capabilities by providing smart experiences and lower end devices. And this is also operating system which provides hardware and software resources of various devices, and provides platforms for creating applications and services which are essential for functionalities, performance, and user experiences on mobile devices. The final operating system which we are going to discuss is Tizen. So Tizen is a platform for Linux foundations. So Linux foundations, and it was provided by Samsung and Intel. And this Tizen operating system works with Samsung devices, including smart TVs, wearables, smartphones, like that. So even though we saw various types of operating systems in real time, this operating systems also have some various types of constraints. So the constraints are listed here. We will see one by one how these constraints are affecting on the mobile operating systems. So first we will see the constraint as battery life. So the battery life, if you see, the power consumption is a main thing when we are using a mobile phone or laptop. So the battery need to be used by the properly with the operating system which we are using. The operating system need to be more should manage the power consumption by optimizing the background processes and screen brightness, network usage, everything. The next thing is the memory constraints. So memory constraints deals with as the small devices are there, memory constraint plays a major issue where the amount of memory the operating system will be working has more impact how much gigahertz or GB, TB of memory it is being used. So this is one of the limitations of memory constraints. Next one is a storage performance. As the memory we are talking, the next thing is the storage. So since it has a storage constraints where the performance optimization, we can't able to store large amount of files, like some constraints are there. And processing power. So processing power for various recent processing platforms, the power will be consumed more for this mobile operating systems. And again, the multitasking. So multitasking will be a great question of mobile operating systems. The mobile operating system designers need to consider all this cross that is the multitasking issues with this. And the next thing is user interface and experience. So the user interface and experience, like touch screen optimization. So like for example, we can say a fingerprint touching will be a more sensitive one. If it uh, make a small error also, then it will again can't able to recognize the users. So touch screen optimization should be properly done. Screen size and resolutions should be properly made. It should be the users should be more like their eyes, everything, power consumption, everything. And gestures and sensors. So like many operating systems are using sensors like GPS, accelerometer, gyroscope, proximity sensors to provide the functionalities and user experiences. So like enabling these features for location based services or fitness tracking and augmented reality will make the operating system to work more constant. So apart from that, the operating system should be provided with regular updates. Like frequent operating system updates are very essential for fixing the security patches and providing new features and performance improvements. Not only that, it also should be updated without any disrupting of their services. So then the optimization, if you see in optimization, like how we are supporting some gestures, facial gestures or swipes, pinches and other touch based interaction, virtual keyboards, voice input methods should be properly made. And the connectivity and communication of the protocols like voice calls, messaging, video calls, internet browsing, integration, social media, everything should be done properly. Not only that, it need also to be considered with multimedia support, like multimedia playback, recording, streaming, integration with camera hardware, photo, video captures. All these things should be taken care. Then finally, the cross device of compatibility should be there. So many mobile operating systems are designed to across a different different devices like smartphones, tablets, wearables, and smart home devices, ensures a consistent user experience and seamless data synchronization. So all these constraints should be taken care uh, with uh, with proper functionalities of mobile operating system, which ensures they meet the need of the experience of the mobile users. So these are the like interoperability, localization, and regulatory complaints, privacy laws. The mobile operating system should follow the privacy of a user and health and safety standards. So this is very very important, because the health wise, the radio waves should not affect the users. When we are going for 5G, 6G and all, more number of radio waves will be there. So proper health measures should be done and safety standards should be given. Proper encryption, decryption, authentication should be given. And language support, the localization and accessibility, if you see, the localization languages should be done. And like various constraints and characteristics are there while designing the mobile operating systems. So hope you understand the characteristics and constraints of a mobile operating system in this lectures. Soon we will meet with next video lecture. Thank you. Hi, in this video lecture, we are going to see regarding hyperlane. So hyperlane is a high performance lane which is referred as Hyperlink. So it is a high performance communication technology. So which is derived from regular local area network environment, which accomplishes multimedia communication with the asynchronous data rate of 23.5 Mbps. Not only that, this hyperlane also provides the functionality for ad hoc environment. If Next, if you see hyperlane is a standard technology which was especially used to create LAN extension via access points. So hyperlane also can functions the need of any kind of access point infrastructure. The interesting thing about it is it was evolved in 1992, and then in 1995 the standard was released. So this hyperlane operates in 5.15 gigahertz to 17.1 gigahertz frequencies, and the throughput of 23.5 Mbps and 50-meter coverage, and it operates in less than 10 milliseconds mobility. So the hyperlane technology also can be work with or without the central control. That is, it can work with wireless networks or with ad hoc networks. That is with the base station to mobile station. That is the wireless communication in ad hoc network without any network deployment. It can work as a single node can act as a both the router and server client like that. So this technology is adopted for both this environment, and it is a packet oriented structure. It supports the communication for packet oriented technologies, and this the bandwidth achievement of this technology is 13.4 Mbps with 25 audio connections at 32 kbps with a maximum of latency of 10 milliseconds. Then the hyperlane, as we saw, hyperlane was used to access with various ad hoc environment as well as the centralized infrastructure. So it is compatible with the normal Mac services for the Mac layer and supports programs can do higher above higher layers. And if you see, there is various versions of hyperlane, like hyperlane 1, hyperlane 2, like that. Hyperlane 1, the purpose of creating Hyperlane 1 was like multimedia supported, and it also work with centralized infrastructure. And Hyperlane 1 is efficiently supports modern real-time audio and video streaming like that. And Hyperlane 2, so the Hyperlane 2 offers a short range wireless connectivity to wired networks. Like the best examples are ATMs and IP communications like this. So if we see the difference between Hyperlane 1 and Hyperlane 2, are the Hyperlane 1 are based on OFDM technology, and this hyperlane 1 uses Gaussian minimum shift keying technique, GMSC, whereas the hyperlane 2 handles the handoff. I hope handoff is not, handoff is the thing where one mobile network moves from one area to another area, the handoff taking place, which we already discussed in GSM networks. The handoff to the closest access point, automatically it is handed over in hyperlane 2. So that is automatic handoff is happening in hyperlane 2. And this hyperlane is a radio, uses a radio base station, so where it can access the range with 30 to 150 meters. Like the best example of hyperlane 2 is mobile ad hoc networks. Like it also schedules various MAC data, and the distributed connections are supported in hyperlane 2. In hyperlane 2, it also achieves high speed transmission rates of up to 54 mbps. And similarly, like hyperlane 1, it also uses OFDM technology, which is used for avoiding interferences in communication. It also provides connection oriented communication with the traffic and unidirectional links and broadcasting link and multicasting links and bidirectional lines with mobile station. So that is the main advantages of hyperlane 2. Now we will see the architecture of hyperlane. So hyperlane, as we saw, it uses OFDM and connection oriented services and everything. So here you can see the hyperlane 2 architecture. Here it has various access points. This hyperlane example is used with the fixed networks. So fixed networks, that is, it has some base stations, and through the access points the mobile nodes are communicated with the hyperlane network. The hyperlane 2 technology is used for application neutral due to its ability to work with almost all kind of fixed networks. So the hyperlane 2 networks are also a solution for providing internet and remote access, like providing hotspot connections in hotels, airports, and wherever day-to-day life we are using. The hotspots connections can also be provided with this hyperlane architecture. I hope you understood the working of hyperlane and versions of hyperlane and differences of hyperlane and hyperlane 2 in this lecture. Soon we will meet with next video. Thank you. Hi, in this video lecture, we are going to discuss regarding Bluetooth architecture. So, Bluetooth architecture is a technology which is used for data and voice transmission over short distances. So, Bluetooth technology offers data connections over short distances like wireless personal area networks. Especially, they are used only for wireless personal area networks. So, who had invented this? It was invented by Ericsson in 1994, and it works between 2.4 gigahertz to 2.485 gigahertz in the unlicensed business, scientific, and clinical communications. So Bluetooth can operate between 10 meters ranges of the communication. So the Bluetooth also displays at least 1 Mbps or 3 Mbps communications. The Bluetooth communication uses frequency hopping spread spectrum technique, that is FHSS. So the collection of a linked Bluetooth piconets will are referred to as scatternet, and various versions of Bluetooth are available. One is piconet, another one is a scatternet. We will see it soon. Bluetooth architectures are using radio waves for data transmission and receptions. The Bluetooth architectures can be linked with the connections which are need to predict a communication range. So a network known as piconet is created when two devices begin to share data. So for example, one mobile phone to another mobile phone, when we are transferring data, that time the piconet forms. The features of Bluetooth involves it can transfer data at a speed of 720 kbps, and Bluetooth gadget is a wireless gadget. It can operate with low cost and short range of communication, and piconet, that is two devices or two or more devices can join and forms a fundamental architecture. So it has two types of architecture. One is piconet, another one is scatternet. A piconet is a kind of Bluetooth architecture where seven slave nodes can form as secondary nodes, and one master node will act between them. So they can have eight active nodes totally, and where they all can act with the 10 meters range. So if you see further with piconet, it also provides one-to-one or one-to-many communication, and between primary and secondary nodes. So slave-to-slave communication is impossible. Only it can communicate with master to slave, and only communication between master and slave is feasible for this Bluetooth architecture. So for example, it can have 255 parked nodes, which are secondary nodes that are unable to participate in communication until they are changed as an active state. So active state nodes can only participate in communication. The next architecture is a scatternet architecture. So what is the difference between scatternet and the piconet is? With a variety of piconet is known as scatternet. Here a slave node is a part of piconet which can take a role of master or main computer. It is known as piconet. In one piconet, this type of node can receive a message from master and the another can function as one can function as a master and sends transaction to slave nodes. So a bridge is used to communicate between these kind of nodes, and um, it is impossible for a master to only a master cannot able to transfer communication between these piconets. So a scaternet is a part of piconet and piconet, and here we need a slave node to communicate between two masters. So here a master cannot be there to communicate between the master to master. So a collection of piconets are known as scaternet. Now we will see architecture of Bluetooth stack. So in this architecture, you can see a radio layer below layer. The radio layer, it is useful for air interface communication. So it operates with frequency hopping and transmission power. Then radio signals are using modulating and demodulating of informations. So this Bluetooth architecture distinguishes between two kind of physical links, that is whether it is connection oriented or connectionless. Based on that, the transactions are happen for this. The next layer is a broadband link controller. So in this broadband link controller, it is similar to MAC layer in normal OSI architecture. So this baseband link controller uses the basebands for digital brands of Bluetooth systems. So it handles timing, power control, packet formatting, addressing, and connection formation inside a Piconet. The next thing is a protocol, that is a link manager protocol, LMP. It handles the management of links between the connection establishment, and it also includes the connection of encryption, authentication, all these things. And it also uses some cutting edge technologies. If any failure occurs, all the link communications are handled with this link manager protocol. Then next thing is L2 cap. So L2 cap is a logical link control and application protocol. So logical link control and application protocol permits the communication between Bluetooth protocol stacks with both upper layers and lower layers. It formats the data packets that are received from higher layers into the format to the lower layers. So it just does the formatting of packets forwarding to upper layers to the lower layers, and it also carries multiplexing and segmentation for the below layers. The next thing is SDP, that is a service discovery. So service discovery protocol. So service discovery protocol is used for services which are communicated with other Bluetooth devices. Then next thing is RF communication layer. In this RF communication layer, this protocol replaces the cable. That is here the RF radio communication uses OBEX. OBEX or WAP for serial interface. So additionally, it also offers a serial communication like L2CAP, that is logical link control application protocol, and this is also useful in this RF communication. The object exchange, this OBEX is an object exchange. So this protocol allows two devices to exchange objects. So the wireless access protocol is used for connection with internet things. And next is TCS, that is telephony control protocol. This telephony control protocol offers phone services, and this layer's primary duty is to group administration and call control for the gateway, which serves which services for numerous services. Then it uses various applications. User interaction applications are used with this application layer. There are several applications and variations of Bluetooth which are available in the market. For example, we can see a car headset is a type of Bluetooth services. Cell phone calls, car speakers, stereo headsets which are used in cars and homes. and still we can have a web camera. This also application of Bluetooth, and printer with Bluetooth capabilities can be used to access from mobile phones to printers. Bluetooth can also be worked with GPS global positioning systems in cars to communicate where the car is moving and directions of the car. All these things are happened with this Bluetooth. I hope you understood the concept of Bluetooth. Soon we will meet with next video lecture. Thank you. Hi, in this video lecture, we are going to discuss vehicular ad hoc networks. So, vehicular ad hoc networks are used for communication with vehicular networks such as cars, and who are going on mobile nodes like that. So it is a cellular communication technology where one node can communicate with another node in a eco-friendly manner with self-organization architecture. So here you can see the architecture of vehicular networks. The vehicular networks are used to acknowledge the necessity of ad hoc vehicle networks. So it is a type of ad hoc networks, means without any routers these networks can form a self-organized nodes and they can act between them whenever the necessity comes for the communication. So this networks was initially governed by US Federal Communication Committee with 75 megahertz and uh, 5.9 gigahertz spectrum for vehicular B2B communication. So these vehicular communications are can communicate with vehicle to vehicle, which are known as B2B networks, and from vehicle to infrastructure also they can communicate, which is known as V2I networks, and in both manners they can communicate. So this networks uses dedicated short range communication, that is DSRC, for communication between V2V and V2I networks. This vehicular ad hoc networks also uses DSRC, that is a dedicated short range communication with internetworking for a lot of attention in recent years. This vehicular ad hoc communications are also used by academic institutions and big automakers and various government organizations for working in vehicle networks. So they are using roadside access points where mobile nodes, sensor networks, static networks, and wireless connectivity technologies can communicate with them. So this vehicular ad hoc networks can also as a I2V networks, that is a point-to-point vehicle access, that is from infrastructure to vehicle and vehicle to vehicle and vehicle to infrastructures. All these things can be used with this vehicular network. So in this diagram everything is clearly mentioned. So with infrastructure to vehicle, and with here this is also infrastructure to vehicle, and this is a vehicle to vehicle communication, and inter satellite communications, eye to eye communications are also possible with this vehicular communications. So in this vehicular networks, it uses many hops like one hop or multi-hop based on the necessity with the help of GPS technology. The primary function of this vehicular networks are they are provide used for communicating with the drivers, people who are in the networks, who are in the cars. Especially this vehicular networks are deployed in situations of accidents or in any emergency situations of communication with the vehicles, people who are traveling. So this vehicular ad hoc networks are having high processing power, and it has lot of storage capacity, enough energy and node movement with the communications. So these networks are usually widely used for network traffic management, and especially are used with security purposes also. They are used in vehicle communication. Now you see in this it uses only two components, one is RSU, another one is OBU. So the RSU is a roadside unit and an OBU is a onboard unit. The OBU is usually located inside the vehicle, and RSU is typically created in the pathways of the traveling. So along the path, every RSU is connected to every other RSU, and the primary roles of RSU are they can send messages to other OBUs and as well as the RSUs. So in that way, the bayonet communication is established, and protecting it also uses various applications and add-on services to provide and alert accidents, traffic scenarios, and the OBUs are used to provide internet connection for the vehicles which are traveling. So these are the main things with this components. Now we see characteristics of VANET. So characteristics of VANET are having various characteristics like estimate of movement. So in highways or when we are traveling, pedestrian walkways, crossing restrictions, vehicle mobilities, and various types of activities, these vanners with the help of RSU and OBU they can communicate with each other. Then power limitations. So vanners are not limited to power because all vehicles are equipped with extended battery life, so there is no power limitation for this vanners. Next is variable length density. In this variable length density, the density of the network is a big contingent upon large volume of traffic in the roadside units. It provides a higher density of populated and urban regions, also rural areas. So the network density won't be an issue for this vehicular ad hoc networks. And then mobility, obviously it is an ad hoc network and it provides faster access for the vehicular communication like V2V, V2I, all those things. So there is no issues with this mobility. Next is variable network topology. Since it moves, the vehicular ad hoc topology works in moving mobility. So whenever the mobility occurs, there is a situation for attacks. Like various malicious attacks or malicious vehicle can disrupt the network communication. So the concentration need to be given for providing solutions of this banner security. Then real-time constraints. The real-time constraints are like data transfer between the nodes with some threshold points are needed, and then processing and storage capacity. And while processing and storage capacity of vehicle, the processing is with the cars, and storage capacity is difficult to use because of the space constraints. And volatility provides the adaptability of the interaction of two nodes for a limited amount of time. It will remain with wireless hops. So the challenging is it should guarantee the privacy of a personal context of VANets. And the next thing is processing. So the high processing capacity need to be taken care with sensors and mobile nodes. And the mobility with nodes can be given with the help of GPS, and it can be adapted to larger span of networks with neighborhood things. So hope you can understand the basics of VANet vehicular ad hoc networks. So soon we will meet with the next architecture. Thank you. Hi, in this video lecture, we are going to discuss ad hoc on-demand distance vector routing protocol. The ad hoc on-demand distance vector routing protocol has the base from DSTV protocol. So, DSTV is a destination sequence distance vector algorithm, which is a variant in distance vector routing method. So, the DSDV is also effective for creating ad hoc networks for small population of networks. So the DSDV also has the mobile node to maintain the complete list of routes, one for destination within the ad hoc network. Whereas this AODV, whenever a routing is needed, whenever the node need to create or establish the routing, that time only it is being established. So this ad hoc on-demand distance vector protocols are purely on-demand distance vector routing algorithms. So the AODV does not depend specifically on the aspects of physical measurements across which the packets are disseminated. It's developed largely for motivated by broadcasting the uh, packets in the infrared or radio frequency of the wireless communication. So AODV uses symmetric links between neighboring nodes where it does not follow the path between nodes, which is one of the nodes cannot hear the other one. So the main purpose of ad hoc routing algorithms are based on various objectives. Here we have highlighted three objectives. So the node does not have to discover or maintain a route to another node until two node needs to communicate. As it is since why? Because it is a on demand. So whenever it need any connection, that time only it can establish the connection. Then when the local connectivity of the mobile node is of interest, each mobile node can become aware of the other node's neighbors. So how it is maintained means by maintaining a local connectivity, that is local broadcast message such as hello message. So the main goal of this algorithm is to broadcast discovery only when necessary, and it also distinguish between local connectivity management, that is who are all in its neighbors, and general topology maintenance also. Then finally disseminate the information about changes in the local connectivity, that is the neighbors whenever the node is joining or leaving the network, that time the disseminated information to whom it can communicate, it can drop from its table, everything will be given by this nodes address. Now the first step is path discovery. In path discovery, so every node need to maintain a two separate counters. The path discovery process is important whenever a source node wants to communicate with another nodes in the routing information. So in order to do that, it does the broadcasting of the information. The source node discovers the broadcasted route request. So for that it uses RREQ, that is here it is highlighted RREQ. So RREQ packet, that is route request packet. So route request packets contains the following informations like source address, source sequence, broadcast ID, destination address, destination sequence number, and then hop count. So the pair source address and broadcast address, that is source address and broadcast ID, uniquely identifies a route request broadcast ID, which is used to determine whenever a source issues a new RREQ number. So each neighbor either satisfy the RREQ by sending a route replay. So if the particular node is having response, then it sends the route replay message. Hey, I'm having a replay route for you to communicate to the particular node, like that a route replay message will be sent by the neighboring nodes. And the node sometimes the node may receive multiple copies of the same route broadcast packet from various neighbors. When an intermediate node receives a route request, if it has already received route request with the same broadcast ID, that is the source address, it drops the redundant route request and does not rebroadcast it. If a node cannot satisfy the route request, it keep tracking following the information in order to implement the reverse path setup as well as the forward path setup, which is a transmission evaluate eventual for RREP. So in order to do that, the RREP packet uses destination IP address, source IP address, that is destination IP address means the source node which it wants to transfer to the destination node. Like this is a source node, and this is the destination node. Now here if we are having some intermediate nodes, so the intermediate nodes, if they are not the destination nodes, then that is it will broadcast further like this. So the broadcasting is done with the help of this RREP packet. So here if you see it has this following information, that is destination IP address, source IP address, broadcast ID, expiration time for the reverse path route entry, and source node sequence number. So these are the things happening with this RREP package. Now the reverse path setup is need to be established. So the reverse path setup consists of two sequence numbers. They are source sequence number and the last destination sequence number. the destination sequence number is used to know the freshness of the route. That is, whenever a node has the highest sequence number, then that time it will conclude that it has the fresh route, means still it can forward or receive messages from the packet. So the destination sequence number plays a major role in identifying the paths. So as the RREQ travels from a source to various destination nodes, it automatically sets up the reverse path from all the node back to the source node. So to set up the reverse path, a node records the address of the neighbor from which it received the first copy of the RREQ nodes. These reverse path routes are maintained for the entire length of the route request to traverse the network and to produce the reply to the sender. We will see how the similarly as we saw reverse path, forward path also maintained similar basis to forward the route request message. So next we will see how the routing table is being maintained. So but why we need to maintain routing table? First we will see the source and destination sequence numbers and other useful information is also stored in the route table entries where the source state associated with the entry. The association with reverse path routing entries like a timer, a route request, expiration timer, everything will be maintained. The purpose of this timer is to purge reverse path routing entries from those nodes that do not lie on the path from the source to the destination. The expiration timer depends upon the size of the ad hoc network. In each routing table entry, the address of active neighboring through which packets for a given destination are received is also maintained. A route entry is considered active if it is used by an active neighbors. Then then a mobile node maintains a route table entry for each destination of interest. So like it has a destination mixed of number of hops, sequence numbers of the destination, active neighbors for this route, and expiration time for the route replay entry. Each time a route entry is used to transmit from a source toward the destination, the timeout for the entry is reset to the current time plus the active routing time. So if a new route is offered to a mobile node, the mobile node compares the destination sequence number to the new route to the destination sequence number for the current node. If the route has the highest sequence number, which is having highest sequence number is also chosen. So here in this diagram you can say whenever a source node wants to transfer to the destination node, here it sends a RREQ packet, that is broadcasting route request packets. So parallelly the nodes will form a reverse path setup to send a reply that it has the particular route, so the source node and destination node can transfer the data without any disturbances. So it is a simple scenario where the source destination nodes can transfer the data from source to destination. I hope you have understood the basics of working of route request and route reply in AODV protocol. Soon we will see with the other protocols, and thank you.